Hello everyone, this is Jyoti Singh, postdoc associate, College of Design, Construction and Planning at University of Florida. The topic for today's presentation is indoor localization and tracking of building components and fixtures using ultra-wideband. Building life cycle consists of large amount of data, which is very important to extract, to use, and to follow up throughout the building life cycle. The building life cycle consists of these many stages, right from planning, design, construction, commissioning, operation, maintenance, and demolition stage. The data associated with these building life cycle requires careful management, and if they are not careful management, the building information will be lost and it will be very difficult to understand the building at the later stage. Currently data is contained in steady materials and documents, or you can say paper based static materials somewhat. For example, plan drawings, manuals, blueprints, supply chain orders and all. So all these information are, if they are stored in steady material, are difficult to store and are difficult to access when required at a particular interval of time. It has been found by various studies that the major data loss occur at commissioning stage, because this is very crucial and stage where all the project team members associate different information and collaborate and contain it and then hand it over to the occupant. The acquisition and transmission of data during commissioning is where leads to various loss of information. It's very time consuming, it's monotonous, and requires huge human effort. So, in order to avoid these challenges, it is this research tries to automate the real-time tracking of necessary information associated with relevant elements in specific location for future follow-up. And this process can help us to efficient flow of information. It can link position coordinates with different building components at a different location. It can reduce the cost with the untimely information sharing. So if there will be real time information sharing, then it will save us a lot of money. So, in order to follow up and to automate the real time tracking information, we studied indoor positioning technologies, which determine the position of a person or an object in an indoor environment in real time. There are various kinds of interposition technologies which have different quality attributes. For example, the location, the accuracy, the line of sight requirements, what kind of condition they require, or if there is any requirements or something like that, and what kind of hardware they use. So the objective of this research is basically to study about interpositioning technologies and find out what is the most promising interpositioning technologies which can be used in various stages of construction. So in order to fulfill this objective, we have three sub-objectives. First is review and selection of suitable interposition technologies, then the key features of suitable interposition technologies, and followed by application and use of interposition technologies in construction. So the method adopted in this research was content analysis, and the keywords used were interpositioning technologies, features of UWB, application of UWB, and stages of construction. So here are the list of identified top 10 indoor positioning technologies, which are Wi-Fi, Bluetooth Low Energy. This is basically sibling of Bluetooth. Radio frequency identification, Zigbee, indoor global navigation satellite system, ultrasound range, imagining, geomagnetic waves, image processing, ultra wideband. So and here are the list of some briefs about these indoor positioning technologies. After further review, it has been found that ultra wideband is the most suitable and foremost technologies which can be used to fulfill the requirement of this research. So we adopted ultra wideband. After that, here's the key features of ultra wideband. So here are some strengths. For example, license free, large bandwidth, short pulse, low power consumption, high data rate transmission, etc. Here are some weaknesses. For example, there can be some potential interference on same spectrum. If there is some signal which has the same spectrum, then there can be potential interference and all. There are some opportunities where UWB has been applied or can be used, for example, into navigation, tracking system, localization and position system. And here are some threats which, if UWB can be avoided, can happen. So there are some technologies which can be used in order to avoid these threats. Now I will talk about application and uses of ultra wideband in construction. So for this purpose, I studied 5 years research paper, past 5 years research papers, and found that there was one paper which talks about design, basically talking about indoor scanning, and there were 20 list of 20 papers which talk about the application of UWB at construction stage, mainly talking about resource positioning and tracking, site supervision, and safety management. And there were four papers which talk about operation and maintenance, mainly talking about the planning, non-destructive testing, detection of corrosion, and electrical application control, etc. And there were no research found in the feasibility stage, at its planning stage, and in the commissioning stage. After that, we tried to map the key features of UWB application with the requirement of construction, sorted with different stages. For example, how UWB can enhance different stages if they have been applied. So it has been found that there were least potential of UWB at the feasibility stage, and average potential at the design stage, and has high potential, that is highest potential, at construction, commissioning, and operation and maintenance stage. So with the previous review, it has been found that there are still like research going on at construction stage for the application of UWB, and even at the operation and maintenance stage, but there is no research which has been done in commissioning stage. This can be a potential topic where UWB can be applied, and application of UWB can enhance the information loss and tracking and everything during commissioning stage. So here is a discussion of our research. So UWB, if combined with other digital technologies, can help us in better and consistent information flow. UWB can organize and access location based on real-time information sharing as a part of commissioning of a building. So a owner can reach to a particular location and can scan it using UWB, scan to using AR or something. And with the use of UWB with that particular location, we can extract necessary information. This process can help us providing a simple, inexpensive solution to easily access accurate building information when and where necessary. It can help organize content to location coordinates, and help to track referential information in a time-efficient manner. This will facilitate better coordination and communication between owners and team during project handover and commissioning. Here are some data or information which can be linked with different position location. For example, if there is a TV, we can link how to use that particular TV with that TV. So that kind of information can be used. For example, as built record, if there's some changes which is done, so this as-built record can be linked with that particular location, and the owner or occupant or facility manager can easily get an access to it. Now, to conclude my presentation, I would like to say that ultra wideband is a fast, secure, short range, low power technologies. It can help organize and access real time information in construction. There is a considerable potential to facilitate efficient information flow at the commissioning stage between geographically distributed team members and without the need for a huge IT infrastructure. So, the future work for our research is to develop a framework for component based information management during commissioning stage, and to quantify how much this application can help us in saving time and cost. So, that's all for my presentation. Thank you. If you have question, please email me to jyoti.singh@ufl.edu. Thank you.